Hello again, it's David Giles here for the next lesson of Cambridge International Education IGCSE Physics, Unit P3 Waves, and today we are looking at dispersion of light. So I want you to recall the order of the spectrum of colours, sometimes known as the order of colours of the rainbow, and explain and describe the process of light dispersion. So, the colours of the rainbow are red, orange, yellow, green, blue, indigo, and violet. Now, different ways to remember it. The one I use most often is Roy G. Biv. Okay? And like I said earlier, it's the same as the colours of a rainbow. Now, there's different ways to remember it. Like the way I said, Roy G. Biv, quite often we use the phrase Richard of York gave battle in vain to help you remember it. If you've got your own mnemonic to help you remember it, that's great. That might help you. So we've got different colours, and these are in deliberate order. There's a reason for it. We'll come back to that reason a little bit later. So question is, why do we see red light as red? Now, the reason for it is quite simple. Each different colour has got a different wavelength, and red has got a certain wavelength which corresponds to red. And if we go back to the colours of the spectrum here, Richard of York gave battle in vain. So violet, which is the last colour, has got the shortest wavelength and highest frequency, whereas red has got the longest wavelength but the smallest frequency. So splitting white light. A prism splits a ray of white light into the colours of the rainbow. This is known as dispersion. The colours that make up white light are called a spectrum. So dispersion occurs because different colours of light refract differently. So you've got refraction going on inside the prism. Red light refracts the least, violet refracts the most. So the order of the colours in the spectrum is always the same as what we mentioned earlier. Richard of York gave battle in vain: red, orange, yellow, green, blue, indigo, and violet. Violet even, sorry. So why does light disperse this way? So remember that light is a wave, and this here is the wavelength from one peak to another. The size of a wave is measured from one peak to the next and is called its wavelength. The shape of the prism means it is spread out even more on leaving the prism, like this. So they are refracted inside, then they are refracted again when they leave. You see a small spectrum with a rectangular glass block, but the colours do not spread out as much. So the white light is made of all colours of the rainbow. Each colour has its own wavelength. Red has the longest and violet has the shortest wavelength. When light enters a glass prism, it slows down. So we're talking about white light, which is made of all the colours. But the shorter wavelengths slow down the most and so bend more sharply. Blue is a short wavelength. Red is a long one. As each wavelength or colour slows down at different rates, it therefore has different angle of refraction to the rest. This means the different colours spread out. So remember, blue bends at best. Now, in reality, it's violet because that's the last one. However, violet bends best doesn't really sound easy. It's not quite as easy to remember. So blue, which basically means stuff at that side of the colours of the spectrum, bends more. So this here is white light splitting. So, pardon me. So this is the order. So red deviates the least, violet the most, or remember, blue bends best. Okay. And that is basically what is happening. This dispersion is happening with a rainbow. Now, you can also use a second prism to then recombine the colours into white light, but that is a little bit tricky sometimes. A key word we're going to use here is monochromatic. So we can split that into two parts. Mono means single, chroma means color. So monochromatic light is light of a single color, so therefore light of a single frequency or single wavelength. Okay, so let's have a look at some exam questions on from paper 2 on what we've looked at so far. White light enters a glass prism. The light then leaves on the other side of the prism separated into colors. Which row correctly describes what happens? Path taken by the light is a diagram 1 or diagram 2? Well, it is splitting inside the prism as well. So we know it's going to be diagram 2. So we know it's either C or D. Color 1 is going to be the one that bends the least. So that's going to be red, and color 2 is violet. So therefore, the answer is C. Next question. Which color of visible lights are in the correct order of increasing wavelength? Okay, so the one with the shortest wavelength is the one at the end. So Roy G. Biv, if we think back to that, it's violet is the least. So you've got the shortest wavelength, then it's indigo. So it's going to start with indigo, then green, then red. So the answer is C. Next question. Which statement describes monochromatic light? It's light with a single frequency. Okay, diagram here. Some light is reflected on striking the prism, and some light is refracted and dispersed to form a spectrum. What happens if monochromatic light is used instead of white light? So let's have a look at the options. The light changes color. Well, that can't happen. So if we use the example of red light, it can't just change color. The light forms a brighter spectrum. If anything, some is going to be reflected, so it's going to be less bright. There is no reflected light, still going to be some reflected. There is no dispersion of the emerging light. So that is correct, because there's only one color, it's monochromatic. It can't disperse, so it is D. The next question here. Which diagram shows dispersion of white light by a glass prism? So we know it splits inside the prism, so that rules out A. We're going to have red on the top, violet on the bottom. That'll be the same inside and outside. You can see here that means the two options, in fact, there's all three of these show that. However, if we look here, the red light, the red and the violet appear to be parallel with each other, which they wouldn't be. Same here. When they come out, you can see red and violet are parallel. So the answer is therefore B, because they are coming out at different angles. And beam of light consists of yellow and blue light. The beam of light is incident on a glass prism. Which diagram is correct? So it's yellow and blue. So if we go back to Roy G. Biv, you're going to have blue bending best. So we're going to have yellow on the top, blue on the bottom. We know that. So we know it's therefore either A or D. It's going to refract, when it leaves the prism, it's going to refract away from the normal. And it's going to refract down the same. So it's going to be D. Okay, the next and final lesson will be on communications, which I will be uploading very soon. I'll post a link in the description. Thank you very much, everyone, and see you later.